the reactions of alkenes. Okay, and we have let's look into first the syllabi of alcohol dehydrohalogenation of alkyl halide, and in detail we have discussed the shades of blue. Even we have discussed trans alkene, this catalytic hydrogenation and Birch reduction. All these we have discussed. Then we have this cis addition that is we get from alkaline K1O4 and trans addition from bromine. Then in detail we have discussed this addition of HX via anti-Markovnikov and Markovnikov rule. Hydration we have discussed, and then we have oxymercuration and hydroboration. So let's start with this hydroporation technique. So let's go into our previous notes. So here we have started with the hydration. So let's move further, and suppose we need to carry out the hydroboration. So we have alkene. Say for example, we have CH3, CH, double bond, CH2. And here this B2H6. In the inorganic part, you will study in detail that this BH3 moiety cannot exist like this. It exists in a banana bond form, in a dimeric form. Otherwise, in case of reaction, we will react it with BH3 only. So suppose there is a reaction. So this is nothing but a addition of water only. This is a hydration process only. The only difference is that is here we will be getting CH2, OH in major amount or as a major product. So since we have discussed the mercuration and oxymercuration, there we get this secondary or tertiary alcohol as a major product. But here in hydroboration, we get this primary alcohol as a major product. Now the question is how? Okay, so let's start with the mechanism. If we see this CH double bond CH2, and if it reacts with this BH3, so what happens is this BH reacts with BH like this, and then this kind of reaction exists. This H goes like this, and this is combined, and this is also like not a partial. This is also getting cleaved. So basically what happens is we get this is a this is intermediate, we can say. This we get intermediate, and then CH3, CH2 and CH2 BH2, we get this moiety. Now what happens is, again this BH2 can be considered like this. This moiety, that is CH3CH double bond CH2, again reacts with BH, and here this is there. So this we can take it as R. So here we have R, and we have one H that is there. Again there is an intermediate which is formed like this. This is being cleaved, and we will get again CH3, CH2, CH2. Now this R is again the same moiety. So this is twice BH. And this is twice. Then what happens is again the third molecule of alkene, that is CH3 CH double bond CH2, reacts with this B, and again this is not the partial bond, and here we have R2. And what is R2? This is R. So this is nothing but CH2 CH2 CH3 hold twice. So basically we will get again CH3 CH2 CH2 whole thrice B. So this is tri alkyl borane. We will be getting this tri-alkyl borane. Now this on oxidation will give you CH3 CH2 CH2 OH. So and plus BOH whole thrice. So basically this way we are getting primary alcohol, or we can also say that we get terminal alcohol as product. Terminal alcohol as product. So that is what happens here. So we will be getting terminal alcohol as a product. So that is nothing but the hydroboration. So now we know two things. Second one is, that is, if we take CH3 CH double bond CH2, okay, and if we react with HgOAc hold twice in the first step, and this in the second step there will be a oxidation and a reduction with NaBH4. And if we take B2H6, that is diborane, in the first step, and then oxidation H2O2. So here we will be getting CH3 CHOH CH3 as a major product. And if we take this CH3 CH2 CH2 OH as a major product, and that is a difference between the mercuration and hydroboration. So basically mercuration and hydroboration both are nothing but the addition of water only, but the methodology and the this method as a whole and the mechanism, the way it follows, give rise to different product. Although directly also we can carry out the hydration we have discussed in the previous class. The only point is then we will be getting mixture of product, and there is a possibility, if there is a formation of carbocation, then there is a possibility of formation of what we say, and rearrangement is also there. So mixture of product will be obtained. So that is nothing but this is the we call it as hydroboration or mercuration. Then there is a one more concept that is there, and one more portion which is there is ozonolysis of alkenes. Even we can take it as from alkynes also. Okay, so that is also one of the concept. Now, if we take CH3, CH double bond, CH2, and here ozone is to be reacted. Okay, so by looking up to the this reaction, we can tell that what kind of product we can get. Say, for example, so ozonolysis, what is ozonolysis? So ozonolysis is nothing but ozone exhibits electrophilic character, and we know that alkenes undergo electrophilic addition reaction. So it reacts rapidly with alkenes. That is one part. Reacts rapidly with alkene in the presence of a solvent such as CCl4. So if we add this ozone, and then we have, suppose, in the presence of a solvent, that is CCl4, then they produce one cyclic peroxide that is there. So the cyclic peroxide, we will get the cyclic peroxide. Then after the cyclic peroxide, the reaction of ozone with alkene result, the ozonoid which is formed. Further, the decomposition of ozonide is carried out by reduction, and which is also known as reductive ozonolysis, or by oxidation known as oxidative ozonolysis. There is one part, that is ozonolysis. Here we have two types of ozonolysis. One is oxidative, another is reductive ozonolysis. Now, say for example, I take up one example of this. CH, and then we will get this kind of moiety. Isolated. So this is nothing but ozone, and this can be or so if it is reductive cleavage, then in the presence of, it will take place in the presence of zinc and water. And if it is oxidative cleavage, then it will take place in the presence of H2O2. So if there is a reductive cleavage, then we will be getting carbonyl compound. So in this particular case, we will be getting CH3 COH plus HCOH. And if it is an oxidative cleavage, then we will be getting CH3 COH plus HCOH. So this is nothing but ozonolysis. Let's change my pen color. Suppose, okay. So what we discussed till now is nothing but what is ozonolysis. That is what is very important. So nothing but so let's discuss first mechanism, and then we will revise everything. So, yes. So if we discuss the mechanism of ozonolysis. So what happens? I will take again the same example. If we have this propene and it reacts with ozone in the presence of CCl4. So what will happen? If I look up into the this ozone as such, as I told you earlier, this is nothing but a electrophile. Now, how electrophile? How it is a electrophile? This is like this. We have oxygen, then we have double bond oxygen, and this oxygen, and we can say that one part is negative, another part is positive. Okay. Now, this happens. Now, how this happens? If we say, suppose a normal ozone is there, so we can write down like this: oxygen, and we have one plus and minus. Now, this can be like this also: minus, and this is double bond plus. Or it can be like this also: uh, one is plus and another is minus. So we can view that how attractively this can react. So we will get CH3, CH, C, H2, and O, 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 and this. This is known as monoozonide. Monoozonide. Now this monoazonide will undergo cleavage like this, and we will get this kind of one moiety. Since the electron pair has gone from here, so there will be a positive charge here, and here we will be getting O and O minus. So basically this electron pair goes at this position. So because of this, we get positive charge here. Because of this, we get a positive charge here, negative charge. And here what happens is, again we will be getting CH2 and very well this thing. Now we see that this is a positive center. This is a positive center, and this is we can say that is this seeks electron because of the electronegativity of this oxygen moiety. So what will happen? This will attack at this position. This will attack, this oxygen moiety will attack at this position. Now, since it will attack at this position, this will attack at this position. So basically what we will be getting, a very smart molecule, nothing but C. Now let me take oxygen, CH2, and then here we have one H, and this is CH3. Here also this is H and this is CH3. So we will be getting oxygen, oxygen, and oxygen. So if I take up this example, so normally what happens is, Let me change the color of a pen. My pen. This is like this. So, what happens is this oxygen. This is there. This oxygen. Oh, I could not change. Let me change. Let me take the highlighter. Okay. If I take the this, so yes. So what happens is this oxygen comes here. Oxygen comes here, and this oxygen attacks at this position. So this oxygen, this oxygen, and this carbon. So this is the new linkage which we have formed. This is the new linkage we have formed, and this moiety is known as, this is ozonide. So this ozonide is formed. Now for ozonide, there is a then again the possibility of what you call it as reductive or oxidative. Suppose we have reductive cleavage, so we will be getting CH3 CH double bond O plus CH2 double bond O. And if we have uh, this oxidative will take place at the in the presence of this H2O2, then we will be getting CH3 CH CH3 CH3 CO, sorry, OH plus HCOOH. So the cleavage will take place like this, like this. This is the mechanism for ozonolysis. Now, once let us revise this thing. So, if we revise what we have discussed till now, is that is one we were just compiling what we have discussed till now. Rearrangement. So there is a mixture of product which we get. So not one is oxy this mercuration. The reagent is HgOAc two twice. So HgOAc twice will give rise to this moiety, and this moiety when it reacts with the, say for example, this moiety. So when it reacts with suppose say for example HgOAc, so what happens is we get major product secondary alcohol, and since there is no formation of carbocationic mechanism, because what happens is there is a this mercury ion which is more electropositive in nature, so there is no formation of carbocation. So because of that we get selective amount of major product. Now, if we carry out the hydroboration, then what happens is hydroboration. The technique is the reagent is B2H6. So first we carry out the hydroboration, and then we do the oxidation reaction. So that is what we discuss. This is a four-membered thing which we get. So basically, uh, if we revise this, so three molecules of this reacts with B2H6 to give you, first of all, CH3, CH2, CH2 whole thrice B, which in turn, when oxidized, will give you the primary alcohol as a major product. Then after that, we discussed this ozonolysis. Now, ozonolysis can be carried out at the double bond or triple bond. Okay, the only difference is, I leave on to you all, that is, if we have one bond, one more bond, so this ozonide will contain this bond will be intact in nature, and accordingly we will be getting the keto group in this parent chain. So that is what has happened. Now, this is again, I am revising. If you take alkene and the ozone in the presence of CCl4, first we will be getting ozonide, and then on reductive cleavage, we get aldehyde, or CH3 CHO plus CH2 double bond. So if somebody asks what is the alkene with this, so if we combine this back, we will get the alkene. So sometimes in exams also is asked, that is a compound A on ozonolysis gives for particular compound. So what will be the alkene? So we can combine this, and we can get this. So that is very important. So this was the ozonolysis part. Now let's go back again to the syllabi. So hydration we did, ozonolysis, oxymercuration, hydroboration, and oxidation. So this completes our this alkene reaction. So that is what is there. Okay, one more very important part I wanted to discuss was this hydration of to form carbonyl compound. That is really very important portion. So let me discuss that also, and very interesting portion. That is reactions of alkyne. Okay, although I have supplied you the materials. Now, very important parameter which is there is this H triple bond CH, or CH3 triple bond, sorry, CH3 triple bond and CH. So they are very, like, this proton or hydrogen is acidic in nature. Very acidic in nature. So that is a very important parameter which we needs to like, we should know this. And if I see this, say for example, mm, not directly with Na. Suppose we have NaNH2, which is a very strong base. So with this strong base, we get this triple bond, and the use of this triple bond is very enormous. Suppose we have CH3C triple bond C minus, and we have RX. So of course this minus cannot exist like this. We will have positive charge here, and there is a release of ammonia. So that is there. And if we react it with alkyl halide, we will get more alkyl halides. So that was one portion that was there in your syllabi also. That is how from alkyne we can get more alkynes. So that is a very interesting portion we should know. That is formation of higher alkynes by reaction with haloalkane. So a very interesting reaction that is there. If you see, look on to the syllabi here, it is conversion into higher alkyne. So preparation acetylene from C, that is there. Let me okay. So, this portion, that is the remaining portion of alkenes, and how alkyne is reactive in nature.